Salam and peace be upon you. My name is Mohammed Layiq Sediqi, the father of Holophase. Remember the language we are learning. There is one field, phi, the holophase, a cyclic rhythm defined at every point in the universe. Its first derivatives give three simultaneous echoes: time, which we call omega; space, which we call k; and motion, which we call v, built from both omega and k. Above them, higher derivatives form a branching tree that goes on forever. Every law of nature is a pattern in this tree of derivatives of phi. Today, we zoom into just one branch of that tree. In the last part, we stepped back and looked at the whole master tree at once. We saw phi at the root, then the first echoes in time, space, and motion, and above them, the endless towers of nuance, topology, waves, and balances. In this part, we come much closer to a very simple but crucial question. Is this structure just another clever code we invented, or is it truly a language that the universe itself is speaking? Let us walk slowly. When people first hear me say the language of reality, it can sound like a poetic slogan. Something nice for a book cover, but maybe not serious. So in this part, we will be very clear. We will separate the idea of a code from the idea of a language, and then we will place the holophase exactly where it belongs. Think of a code you already know. For a moment, imagine Morse code. You have dots and dashes, short beeps and long beeps. Each pattern stands for a letter. A dot dash is the letter A. A dash dot 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 is the letter B. Morse code is extremely useful as a tool. It lets you send messages over long distances using simple signals. But notice something. Morse code itself does not know anything about the meaning of the message. The same pattern of dots and dashes could stand for nonsense or for the most beautiful poem. The code is just a fixed table that says, this pattern corresponds to that symbol. It is like a small dictionary with no grammar inside it. Now think about DNA. Many people call DNA the code of life. In a narrow sense, that is correct. DNA uses 4 letters, usually written A, C, G, and T. Groups of 3 letters map to amino acids. Chains of those groups help build proteins. There is a clear mapping from sequences in DNA to things that cells do. Again, though, notice something important. The DNA code, as we usually describe it, is a list of correspondences. This triplet means this amino acid. It is a powerful code, but still a code. A code, in this very precise sense, is a fixed mapping from one set of symbols to another. There is no deep, built-in grammar. There is no natural way to say, from these basic elements, you can generate infinitely many structured expressions with layers and hierarchy. The code is finite, and its combinations, while many, are not guided by an internal notion of correct sentences or deep structure. Humans can impose grammar on top of it, but the code itself does not enforce it. By contrast, a language is something richer. When I say language here, I am not being mystical. I mean it in a very down-to-earth way, similar to how linguists and computer scientists speak. A language has at least 3 things. First, it has an alphabet, or a set of basic units. These are like letters or sounds. Second, it has grammar rules. These are rules for combining those units into larger structures: syllables, words, phrases, sentences, paragraphs. Third, it has generativity. With a small set of letters and rules, you can build an essentially unlimited number of meaningful expressions. You can form short, simple sentences, long, complex ones, layers of description, stories, and even stories about stories. When you listen to a language like English, Persian, or any other, you're hearing this generativity in action. We are using a small set of sounds and a shared grammar to build a huge landscape of meaning. Most of the sentences you hear in your life have never been spoken before in exactly that way. The language does not just list all possible texts in advance. It gives you a system for generating new ones on the fly. The holophase is like that. The holophase is not a fixed lookup table where one value stands for electron, another for photon, another for gravity, and so on. It is not that we decide that one phase value means 0 and another means 1, and then we write those bits across the universe. That would be a code. Codes are human objects laid on top of physics. The holophase is different. It is a field with a very specific structure of derivatives. Those derivatives are the alphabet. The constraints among those derivatives are the grammar. The whole master tree is the living grammar book, not written outside the universe, but embodied in the way the universe actually behaves. Let us make this very concrete. At the root of the language is phi itself, the basic phase. Its first derivatives in time, space, and motion give us omega, k, and v. These are like the primary letters. They tell us how fast the phase changes in time, how sharply it changes across space, and how a phase pattern moves. Already here you can feel the difference between code and language. In a simple code, each symbol sits alone. A 0 is just a 0. A 1 is just a 1. The code does not care how zeros and ones change over time, how they flow in space, or how they are constrained by movement. In the holophase, omega, k, and v do not exist in isolation. They are bound together. If omega and k satisfy a certain relation, then v is fixed. If they break that relation, the phase structure cannot propagate consistently. This is the beginning of grammar, relationships among the letters that cannot be broken without breaking the whole story. Now, let us climb one level up. Second derivatives like alpha, curvature, convergence, and twist tell us how the first derivatives change. Alpha is how the local rhythm speeds up or slows down. Curvature is how the slope of phi bends. Convergence tells us where patterns focus or spread. Twist and shear tell us how patterns slide and rotate relative to each other. Here again, notice the difference between a code and a language. In a code, there is no higher structure like this. A sequence like 0, 1, 0, 1 might stand for the letter A, but the code does not say that certain sequences of letters must be arranged so that their patterns of change fit certain rules. In the holophase, second derivatives constrain first derivatives. If curvature is high in one region, then the first derivatives must behave in a particular way there. If alpha is large, omega cannot stay constant. These constraints are like grammar rules. They tell you which combinations are allowed and which are not. If you want to see the full mathematical form of these relationships, with the exact equations that tie the derivatives together, you can search for holophase on Zenodo. There, the scientific papers lay out the formal derivations. In this audio journey, we stay with the spoken understanding, but the hard mathematics is there, waiting for anyone who wants to test, criticize, or build on it. So in the holophase picture, we have a hierarchy. Phi at the root. First derivatives as the core alphabet, omega, k, v. Second derivatives as modifiers and constraints, alpha, curvature, convergence, twist, and others. Higher derivatives as finer nuances of change, like the subtle variations in a melody or the intricate stitching in a woven rug. Topological features as discrete anchors, knots, loops, and defects that give us stable nouns, like particle charges. Wave structures as verbs, patterns that carry influence and information from place to place. Quadratic balances as style rules, preferences for certain global patterns that the universe tends to favor. All of this is the structure of a language, not a flat code. Let us now look at this in the three dimensions we always care about: time, space, and motion. In time, the holophase language describes how rhythms unfold. Omega is the local tempo. Alpha is how that tempo changes. Higher time derivatives are like the jerk and snap of a musical rhythm, the way a drummer speeds up or slows down, the way a dancer pauses, accelerates, and glides. If you record a signal from a physical system, light intensity, voltage, position, and look at how it changes over time, you are seeing the temporal side of the holophase language. In space, the holophase language describes how shapes and textures appear. K is the spacing of patterns. Curvature is how those patterns bend. Convergence tells you whether patterns are gathering into tight regions or spreading out into flat ones. Shear tells you whether layers slide past each other. Twist tells you whether structures spin. When you look at the surface of water, at clouds, at mountains, at a crystal under a microscope, you are seeing the spatial side of the holophase language. In motion, the holophase language describes how these time and space patterns travel. V, the motion echo, tells you how fast a phase pattern sweeps through space. Its changes tell you about acceleration, deflection, or orbit. Wave packets, solitons, streams, and flows are all moving sentences in this language. When you watch smoke rising, birds flying, rivers flowing, or light beams bending through glass, you are seeing the kinematic side of the holophase language. These three are not separate languages. They are three echoes of the same structure in phi. The holophase does not write one story in time, another in space, and a third in motion. It writes one story, and we can project that story onto these three screens. This brings us to a very important point about testability. If the holophase language is real, then its grammar must be consistent across all three echoes. If a particular pattern of derivatives predicts that a wave packet should move with a certain group velocity, then we should be able to measure that motion in an experiment. If the same pattern predicts a certain spacing of interference fringes in space, we should be able to see that spacing. If it predicts a certain time rhythm in the signal at a detector, that rhythm must show up when we record the data. In other words, the phi language writes temporal evolution, spatial structure, and kinematic behavior at once. If our description is correct, the predictions in all three domains must line up. If they do not, if the omega kV combination we propose fails to match measured oscillations, shapes, and motions together, then that branch of our language is wrong or incomplete. This is exactly how a scientific language should behave. It is not protected by poetry, it is exposed to experiment. Now, why do I insist that the holophase is not just a code? Because in a code, you can almost freely swap symbols as long as the sender and receiver agree. You could decide that dot dash means B and dash dot means A, and communication would still work if everyone updated their tables. But in the holophase, you cannot arbitrarily reassign meanings. You cannot decide that a certain combination of derivatives will mean electron today and photon tomorrow, independently of the dynamics. The meanings arise from the way patterns in phi behave under the grammar of derivatives and topology. An electron-like entity, in this view, is not a label you attach to a pattern. It is the pattern itself, a stable, knotted configuration in the phase, with specific relationships among its derivatives, specific ways it interacts with waves, specific motion signatures. If those relationships change, if the underlying phase configuration is deformed beyond certain limits, the electron disappears or becomes something else. This is much closer to language than to code. The identity is not in the symbol, it is in the whole structured expression. Think of a word in a spoken language, like river. Its meaning is not just a letter sequence. It is connected to all the grammar rules and experiential patterns around it. You know that the river flows makes sense, and the river sleeps feels strange, because the grammar of the language and your experience of rivers constrain how the word can be used. In the same way, a pattern in the holophase is not just a static code word. It comes with built-in ways it can interact, move, and change. Here is another way to feel the difference. Imagine writing a simple code on paper. You decide that each letter of the alphabet will be represented by a number. A is 1, B is 2, and so on. You write a sequence of numbers. To decode it, you look up each number and write the corresponding letter. During this whole process, nothing is happening in time or space inside the code itself. It just sits there. All the action is in your mind. Now imagine a vibrating string. At each point along the string, the displacement is changing in time. The pattern of the vibration has a certain shape in space, a certain rhythm in time, and certain ways of moving energy along the string. If you pluck it in one place, a wave travels. If you press it at certain points, you create new patterns. This is much closer to what the holophase is like. The letters are not dead symbols, they are living behaviors, and their combinations are constrained by the physics of the system. The holophase language is like a vastly richer version of that vibrating string, expanded to encompass the entire universe. At this point, you might ask, if the holophase language is a language, who is speaking it and who is listening? The honest answer is that the universe is speaking it. And every physical system is both speaker and listener. When two wave packets collide, they are not exchanging pre-agreed code words. They are interacting through the shared grammar of phi. Their shapes, timings, and motions determine how they interfere, reflect, transmit, or form new structures. The listener is simply the future configuration of phi, shaped by the present configuration according to the grammar. We humans, with our instruments and theories, are latecomers. We are learning to read a language that has been spoken by reality long before we arrived. Our measuring devices pick up pieces of the story: time traces, spatial images, trajectories. Our equations are our attempt to write down, in compact symbolic form, some of the grammar that the holophase is already obeying. You might also ask, where does this leave other codes, like DNA or our digital computers? It does not erase them. It places them in context. DNA is still a code, and a remarkable one. But in the holophase view, DNA is a code written on top of a deeper language. The sequence of bases in DNA is a pattern in molecules. Those molecules are patterns in atoms. Those atoms are patterns in fields. Those fields are patterns in phi. The DNA code is like a paragraph written in a regional dialect inside a much larger language. It is powerful locally, but it does not set the global grammar. Digital bits in your phone or laptop are also codes. A bit is usually a choice between two stable configurations, high voltage or low, magnetized this way or that way. Those configurations, again, are patterns in physical systems that obey the holophase grammar. The bits are like street signs in a city. They direct traffic, they carry local instructions, but they do not define gravity, geometry, or light. They operate within a world whose deeper behavior is already written in the language of phi. This is why it matters, philosophically and scientifically, to insist that the holophase is a language, not just a code. Codes are things we design. Languages, at least in this sense, are structures that can generate worlds. Before we close, I want to give you a very practical way to tell, with your own eyes and ears, when you are looking at a code and when you are looking at a language. A code usually has 3 marks. First, you can write it down without it having to do anything. A list of numbers or letters on a page is enough. Second, to use it, you need an external decoder, some agent who knows the mapping table. Third, you can freely choose the mapping, as long as everyone agrees. A language, especially a physical language like the holophase, behaves differently. It does not wait for a separate decoder. The decoding is the evolution of the system itself. When phase patterns interact, they follow the grammar automatically. There is no external table that the universe consults. The mapping between structure and behavior is not arbitrary. It is forced by the dynamics. You can hear this difference if you compare 2 sounds. Imagine first that I read out a long string of random digits. 3, 7, 9, 1, 8. Without a codebook, these numbers are just bare symbols. Now imagine that instead of digits, you hear someone speaking a language you do not know. Even if you do not understand the words, you can feel the grammar. Pauses, emphasis, patterns of repetition, rising and falling intonation. Your brain picks up that this is not noise but structured speech. In exactly this spirit, the Holophase says, the universe is not humming random numbers. It is speaking in structured, grammatically constrained phase patterns. Even if you do not yet know all the words, you can start to sense the presence of grammar in the way patterns persist, repeat, and interact. Let us tie this back even more explicitly to the master tree. On the lowest branches, omega, k, and v act like the basic consonants and vowels of the language. They tell you where patterns are, how tightly they are spaced, and how they move. On the next level, alpha, curvature, convergence, and twist are like accents and intonation. They shape how patterns begin, swell, bend, and fade. Higher derivatives are like complex sentence structures and styles. Repeated rhythms, nested phrases, echoes, and themes. Topology, with its knots and defects, gives us something like nouns and names, stable, countable entities that can appear again and again in different contexts. Wave structures let the universe form verbs and clauses. This influence travels there. This pattern carries energy here. This signal resonates with that one. Quadratic balances and action-like rules play the role of style and coherence. They ensure that the overall story holds together, that it is not just a jumble of unrelated events. In time, this whole tree shows up as layered rhythms. A simple tone is like a short word. A chord progression is like a sentence. A symphony is like a long paragraph. In space, the tree shows up as nested textures, smooth regions, sharp boundaries, repeating motifs, fractal details. In motion, it shows up as trajectories and flows, straight lines, curved paths, spirals, chaotic wandering. If the holophase is truly a language, we must be able to read the same branch of the tree in all three echoes at once. That gives us a clear falsifiability test. Here is one simple recipe you can imagine. First, pick a physical system you can control. A laser beam in a lab, a vibrating membrane, a shallow water tank, or even a computer simulation of waves. Second, measure three things at the same time. How the system changes in time at a few points, what its spatial pattern looks like at some instant, and how certain features move from place to place. Third, try to describe those three sets of observations with a single, coherent set of holophase derivatives and grammar rules. If you succeed, if one set of omega k v and their neighbors in the tree explains all three data streams at once, then the holophase description has passed a small but real test. If you fail, if you need one story for the time trace, another inconsistent story for the spatial pattern, and yet another for the motion of features, then something in this branch of the language is wrong. This is why, throughout this series, we keep returning to the triunity of time, space, and motion. It is not just philosophical decoration. It is the backbone of how we check whether the language we are proposing is actually the one the universe is speaking. To help you recognize this in everyday life, let me offer a short checklist. Whenever you look at something happening in the world, you can ask, what is the rhythm here in time? What is the pattern here in space? How is this pattern moving? If you can answer those three questions in a way that feels connected, that is, if you can say, because the rhythm is like this, the shape is like that, and therefore the motion is like this, then you are already beginning to think in the holophase way. You are no longer just naming things. You are reading relationships. A simple example. A car driving along a curved road. In time, you can feel the rhythm of acceleration and braking, the temporal echo of the journey. That is enough. So as you walk away from this part, I invite you to hold one idea very gently but firmly. The holophase is not a secret code that only a few experts can read. It is a language that reality is always speaking, and that we are slowly becoming literate in. When you hear me say language, I want you to think of An alphabet, phi and its derivatives. Grammar rules, constraints and relationships among those derivatives. Generativity, infinite possible patterns, from simple waves to complex organisms. Dimensional echoes, every pattern heard in time, seen in space, and traced in motion. Falsifiability, the requirement that all three echoes match what experiments show. If any part of this structure fails against reality, we learn and adjust. That is the promise and the discipline of treating holophase as a scientific language, not as a myth. In the next part, we will zoom into one of the deepest features of this picture, the great unity behind all this variety. We will ask how one single cyclic order, phi, can give rise to such an enormous range of structured meaning. For now, let this be enough. You are not just learning a code with a few rules. You are beginning to read a living language, where every wave on the sea, every ray of light, every breath of wind, every heartbeat, and every signal in a circuit is a sentence written in the same underlying script. And you, as a listener on this journey, are slowly becoming fluent in hearing it. Peace be upon you. Until the next part.